Hello everyone, welcome back. This is Engineer Sam Wasabi. So in this video we'll be looking at a continuation of our physics problems. Alright, so before we begin, do not forget to like and subscribe to the channel. Alright, let's get to it. So the question says that figure B1.1 below shows a simple pendulum suspended from a fixed point, as you can see in the figure that we have here. So we have the string, the bulb, and the two positions, that is A and B. Sorry about that. Now the bulb is slightly pulled to position A and then released. Now the first part of the question is asking us to state one fact that it does not affect the period of the pendulum. So I'll be putting my answers on this side of the screen. So now there are several factors that do not affect the period of the pendulum. To start with, we can mention the mass of the bulb. Now the mass does not appear in the equation of the period, indicating it has no effect on how long a swing takes. Not only that, if we would want, we can also include air resistance. Now, typically negligible in most conditions, though it can dissipate some form of energy and reduce amplitude over time, but this has no effect on the period of the pendulum. Now moving on to B, it says if the values of time for 20 oscillations obtained were as follows, which is 16.1, 15.9, 16, 16.2, and 15.8. Calculate the period of the pendulum. Now, to find the period, which is just capital T, we know that this is basically time over the number of swings. Now, to find the time, in a case where we have a sequence of different time intervals, all we have to do is to find the average time. Now, how do we find the average time? So you can say data, and say to find time, we'll have to sum up all the time intervals that we have, which is 16.1 plus 15.9 plus 16 plus 16.2 plus 15.8, and divide this by the number of time intervals, which are basically 5. So if we do our math right, we'll have the time being equal to the sum of the numerator will give us 80 divided by 5, and 80 divided by 5 is 16. So we have 16 seconds. That's the average time. So to find the period, we say T is equal to time, which is 16 over number of swings, which is 20. And 16 divided by 20 will give us the period of the pendulum to be equivalent to 0.8 seconds. C says calculate the frequency of the pendulum. Now, frequency is the inverse of the period of time, which is the period of the pendulum. So frequency is 1 over the value we found, which is 0.8, and if we say 1 divided by 0.8, we get to have a frequency of 1.25 Hz. And that's how we go about solving such a question. Alright, see you.